Hi, in this video I want to talk about errors in Java and then a mechanism that Java and other languages use called exceptions that allow you to respond to those kinds of errors. So first of all, we want to review these errors, learn about exceptions, and then basically how you structure code to use these exceptions properly. There's some famous quotes about errors in code. So if debugging is a process of removing software bugs, then programming must be the process of putting them in. And certainly it does feel like that some days, right? That you just write stuff and nothing is going right. And then the first 90% of the code accounts for the first 90% of the development time. The remaining 10% of the code accounts for the other 90% of development time. And of course that doesn't add up to 100, but I think it reflects what happens with many of us, which is we make a plan in our mind. Oh, I'm going to write code for, 4 hours, and then I'll spend an hour cleaning it up and making sure it all works and stuff. But in reality, the time is often flipped, right? You might spend 2 hours writing code and then 10 hours debugging or something like that. And it's important to recognize that process of making your code work properly is both time consuming and kind of painful, but you need to account for it. It's very rare to write something and then have it just work right off the bat. And of course, the better you get at debugging, the more time you save overall. So I would really encourage you to work on your skills with a debugger and thinking about how to look at code issues in a targeted, careful way, and figure out how to make progress debugging code. So some errors and ones that are common in introductory courses in code is errors that are found at compile time. So you write code and hit run. Really, the first step, remember, is that it compiles the code. And it says, hey, there's something just wrong with the code. Missing semicolon, maybe a type mismatch. So here we have a method that returns an int, and we call that method, and then we try to assign it to a string, right? And that Java can recognize in advance. It doesn't have to wait for the one to come back. It just knows that the int and the string don't align, and so whatever answer comes out of here is not going to be workable. And again, we get used to seeing those, but those are fairly easy to fix. You get like a line number, some kind of message describing it, and you just have to kind of recognize where you're not using the Java statements properly. Logic errors are one where you write the code and it compiles and runs, but the solution has a flaw. And to me, these are actually a little harder to find. You have to kind of convince yourself that something is wrong in the first place, and that's often done through testing. And then you have to fix it, and really you have to check the flow of data all along your program and making sure it stays consistent with what you expect. So here's a factorial program, like n exclamation point that calculates that kind of number. And again, you can figure out the error through inspection. Like here, you recognize that I have a 0 here, and then I multiply that 0 by something, and that's always going to stay 0. But really, the better way to do that is to debug it and say oh, I was 0, and then I stayed 0. Print it out, and you see that factorial is always 0, 0, 0, 0, 0, something like that. In fact, there's also we're not changing the count. Count should be plus plus here or something like that as well. So there's multiple problems, but that requires you to actually run the program and look into it. And again, just staring at the code is not the right answer here. You need to run the program. Now, a runtime error is something that the program runs, but it crashes as it runs. And so that can be, for example, if we try to divide 4 by 0, you get a divide by 0 error. You can have an index error. So here, here we have a word with high in it, and I'm going to try to get a letter out of it. And maybe I'm forgetting, the index starts at 0, so I'm thinking I'm getting the second location, but I'm really asking for the third location, 0, 1, 2. And if I were to run this, well, we saw some red flash by here. We get something called a string index out of bounds exception, and it says 2 is too high. And of course, it tells you, where this is happening, right? I can click on here and find it. But notice it's not a wrong answer. It's just the program stopped as we were running it. And of course, that's a terrible thing. You don't want programs to crash. These are not necessarily things that can be caught in advance. I mean, here I could tell something was wrong, but maybe I'd ask the user to say, what letter do you want? and I didn't, properly check it. Maybe this was based on some results of some computation that was hard to predict in advance. Maybe it was a random number kind of thing. So you can't always make it so that you sort of know in advance whether or not these situations are going to occur. And particular stuff like opening a file that doesn't exist, which we'll talk about later, you can't guarantee it's maybe on a system. It may even disappear in between checking for it and then when you actually try to open it. Okay, so Java uses a mechanism called exceptions to respond to runtime errors. And essentially, you try some code. So there's a keyword try and a keyword catch. And you try a block of code. And that code may cause a runtime error of some kind. And in fact, either your code or the code that you call, like the methods that you call, can do what's called throw an exception. And when that exception is thrown, it is caught down here. And this is sort of like a method, this is like a parameter kind of, but it's fixed, right? You don't have any choice here. The throw says what kind of exception it was that caused this, like a string out of bounds or file not found, that kind of stuff. And then you have some code to respond to the exception. So I could, for example, wrap my hey, what happened to my my code here in one of these try catch kind of things. So I'm gonna add in a try, and there's a code block associated with a try, and I'll add in a print just to, for you to succeed, I want to print out the character, right? So I'm just going to print out letter. And then there is this catch. And I have to specify the kind of exception that I'm expecting to catch. And so I know in this case the exception that could happen is this, and it's sort of ridiculously long names, right? String index out of bounds exception, and you have to give it some name. Now E is not a great name for most variables, but somehow with exceptions it's pretty commonly just an E here, so I'll stick to that plan for now. And in here I'm going to print out some kind of message that something bad had happened. Index out of bounds, and maybe that's all I'll do here. There I am exiting the program, but maybe I'll continue on here. And in fact, let me add on a little bit more here. Going on, like in other words, continuing. Okay, so first of all, let's put in 1 here, so I'm not going to cause an error. Let's see what happens. And of course, I can't see anything at all. Okay. So if I say 1 here, it got out at location 0 and then 1, I. It stored I in the letter, and I printed it out, and I see the I. Since no exception happened, it skipped over the catch. In some ways, this is kind of like an if-else in some ways, right? Like this only happens if this stuff doesn't finish up properly. And then I continued on and printed out going on here. Now if let's just put a real big number 3 in here, and I run it. It doesn't crash anymore, right? So that's the first thing. The program actually runs. It prints, and the exception happened here. The exception gets thrown by the code in this charret, and it is caught here, and it does catch the string index out of bounds exception, and it prints index out of bounds, and then goes on and prints out this going on. So notice it skipped this line here, right? It was thrown from here and got caught, did this. It didn't jump back in and try to keep going or something like that. It just, as soon as the exception is thrown, it jumps past anything in the try, goes to the catch, does the catch, and then finishes up that whole statement, and then continues on whatever's next in the program. I'll also point out that letter here only has a scope in here, so if I were to try to print out letter down here, I'd have trouble. So I'd have to declare letter before the try, assign it in here, and then print it out down here, right? So the tries and catch, I think, kind of cause some trouble sometimes with scoping stuff, especially if you have written your code first and then later you wrap it in a try catch to try to handle some exception. So this is a pretty basic approach. You can have multiple catches. So I can, for example, catch a very general thing, which is just exception, also E, and I can just print out something bad happened. Right, I don't know what it is anymore. Actually, the exception does have some information inside it. There's a message you can get to and stuff, but it was not a string index out of bounds exception, and so something else happened here. So I can chain these together, and the first one that matches is the one that gets used for the catch. So typically you have very specific ones followed by more general ones, with the idea that you want to respond as specifically as you can to an error, like and print out like index out of bounds. Now sometimes the try catch's job is to try to fix it. Like you have to figure out like, okay, that was too big a number. Let's subtract it. Maybe there's a while loop here or something like that, and try again. So there's all sorts of patterns we can see using this try catch. Now I'll also say that this is a pretty big statement. We're used to one-line statements. Here's assignment. Here's an if. It's a little bit bigger. This has a lot of stuff going on in it, and it kind of complicates the code. You have to learn how to read these effectively. Now, let me just say that exceptions are for exceptional things that are not expected. Do not use exceptions to handle ordinary logic errors. And so, for example, here's a while loop. It's an infinite loop because it's while true. I try to get the letter at the character starting at 0 when presumes. I index up. So I loop at index 0, index 1, index 2. It throws an exception and I catch it, done. This is a terrible form of like a while loop or for loop. There's performance reasons, but also just complexity reasons. And so do not just pretend exceptions are there to cover up any kind of like laziness on your part or just basic misunderstanding of what's going on in code. Its job is to figure out when something that could not be predicted happened and try to respond gracefully to it. So I will say I see this, people learn about exceptions and get kind of excited about it, but don't just start populating all your code with try catches, trying to avoid just whatever random mistakes you're making. Now, one question is, where should a try catch happen? And really it has to happen where you can do something about it, where you know enough about what happened to respond to it. And sometimes that's not, for example, in where it happened. So for example, I'm going to make here a method to do this out of bounds thing, public static char get letter, and it's going to take in a string. I'll just say sentence here. It's not really a word necessarily. Ugh. And an index, and I'm going to return sentence get char of index. Get char at char at index. Okay. And I'm gonna get rid of this. Well, let me just try this out before we do anything. So I'm gonna call get letter, and I'm gonna found letter equals get letter of word and index 2. And why is it complaining? Oh, it's not used. Okay, and I'm going to print it out. Okay, so if I run this with a 1, it prints out the I from the high, so we pass that in. It gets at index 1, returns that letter, right? If I send in a 2, I get an exception. This causes an exception, and I don't have a try catch around this thing, right? So one possibility is I could do a try catch here, but then what should I return if an error happened, right? I'm saying that I want to return a letter, so I'd have to return like, I don't know what, some funny character that means like character wasn't returnable, and then down here I'd have to do an if statement, basically saying like, oh, if I get this funny character back, then do something with it. So it seems clear that I got to return something. I can't really manage that error up here because I had to send it to someone else that can manage it. And so rather than returning some funny character here for an error, I think instead I'd rather actually say like, hey, you manage this exception, okay? And so the way we do that is there's this throws notation. And we add to, and this gets pretty long now, the keyword throws. Again, this is on the first line of the method, and I'm saying this thing has the potential of throwing an exception. And so I'm going to say what it can throw. String index out of bounds exception. Okay, so it's saying when I call this method, I'm saying it has the potential of throwing this exception. And it's going to be your job here to respond to that. So I'm going to have to, let me just actually move this down. So I'm going to replace this with that call to the getLetter. GetLetter can throw a string index out of bounds exception. It means it doesn't actually crash here. It passes the responsibility on to where it was called from. And this thing has to have a try catch around it to manage that. Okay. So I'm going to run it now, and I got the index out of bounds from this thing here. So this caused an exception. It didn't crash in here because I said, hey, I think it could cause an exception, but I'm not going to handle it right now. I'm going to throw it back to whoever called me. The exception happens here, and I'm actually catching that exception here. All right, so I think, again, this is a better structure in some ways. If I caught it here, I don't know what to do with that. I don't know how to fix it. I don't know how to make it right. So I'm going to say, you call me. You know what happens if you don't have an index there, so you figure it out. And we're just going to print out index out of bounds. So anyway, we have a try catch. We call a method. If that were some Java method that already throws something, we have to have it can catch that error. If it's our own code, again, we can defer responsibility for managing the error to whoever called me and pass it up the chain. So somewhere, okay, I called it. I'm going to figure out what I want to do, what happens when there's not a proper index for it. So again, this is a pretty common structure here to throw these things. You get these long definitions of the method. It has all this stuff on it now, and that's okay. Just understand that its job is to warn other code that's calling it that an exception may happen here, and your job is to catch it. All right, thanks. So that's basically about Java exceptions. There's more to it, and we'll keep using these as we go, and they're an important part of Java.